Hi guys, this is Stage Marky U, your science buddy na magpapaliwanag sa inyo ng mga lessons nyo sa science. For this video, what you're going to learn is about recall the different parts of a wave, define wavelength, frequency, and speed, solve problems involving wavelength, frequency, and speed of electromagnetic waves. All of this is about wave equation, one of the lessons of grade 10 quarter 2 physics. But before anything else, please do subscribe to my YouTube channel and click the notification button para maging updated kayo sa mga bagong video discussions na i-upload ko. So what are we waiting for? Let us now explore the world of science. Before we proceed with our discussion, I have a challenge for you. I will call it, What Word Am I? All you have to do is to rearrange the jumbled letters into their correct order so that you'll get the correct answer. You will be guided by statement above those jumbled letters. You're also given 5 seconds to answer each challenge. Let us now begin. Challenge number 1. A disturbance in a medium that carries energy. These are the jumbled letters. Your 5 seconds start now. The correct answer is wave. Challenge number 2. It refers to the highest point in a wave. These are the jumbled letters. Your 5 seconds start now. The correct answer is crest. Challenge number 3. The minimum or lowest point in a wave cycle. These are the jumbled letters. Your 5 seconds start now. The correct answer is trough. Challenge number 4. It is the distance from the midpoint to the highest point or lowest point in a wave. These are the jumbled letters. Your 5 seconds start now. The correct answer is amplitude. Challenge number 5. It is the distance between two successive identical parts of a wave. These are the jumbled letters. Your 5 seconds start now. The correct answer is wavelength. Challenge number 6. It refers to the number of waves produced in 1 second. These are the jumbled letters. Your 5 seconds start now. The correct answer is frequency. Challenge number 7. It is the unit of frequency. These are the jumbled letters. Your 5 seconds start now. The correct answer is hertz. If you got all the correct answers, congratulations! That's time. Let us have first a short review of the different parts of a wave. So this is a 1 cycle wave and it shows here the different parts of this wave. So let's start with number 1. Number 1 is crest. Crest is the highest point or surface of a wave. So this one is the crest, this one another crest, and another crest. Number 2, that is what we call trough. Trough is the lowest point or surface part of a wave. So this is the trough, and this is also a trough. The number 3, that is what we call amplitude. Amplitude is the distance between origin and crest or trough. So the line here that you can see at the center is what we call normal line or the origin of the wave. So from that origin going to the highest point, and then from this origin going to the lowest point, These are what we call amplitudes. Another one is what we call wavelength. Wavelength is the distance between identical points on consecutive waves. So this is the crest. From this crest to the other crest, that is what we call wavelength. Wavelength can also be found here from this trough going to this trough. That is also what we call wavelength. And last one is frequency. So this is a one cycle wave. For example, one cycle wave for 1 second. So if you want to know the number of frequencies here, all you have to do is to count the number of waves it has created. So we have here 1, 2, 3, 4. So we have here 4 waves. So the frequency of this wave is 4. Let us now proceed with the wave equation. Generally, wave has this equation. V is equal to F times lambda. V here stands for velocity or speed. F here stands for frequency. Then the lambda here stands for wavelength. Please do remember that B for electromagnetic waves will always be C. C here is the speed of light, which is equal or has a constant value of 3 times 10 raised to 8 meters per second. Sometimes, a certain problem does not give the value of speed of light. So if that is the case, the value of speed of light that you will use is this 3 times 10 raised to 8 meters per second in order for you to solve the missing variable in that problem. Wave equation has 3 formulas or equations. If you find it hard to memorize these equations, I'll give you the triangle method in order for you to solve what is asked in the problem. So you will use this triangle method. So how to use triangle method? The triangle method shows here the specific location of the 3 variables. The variables that I'm talking about refer to the velocity, frequency, and wavelength. So the specific location of velocity here is in the upper part of the triangle, and then the frequency is in the left side of the triangle, and the wavelength here is the right side of the triangle. So if you want to know the formula, let's say for example, the missing variable is velocity or speed, just cover it and then it will show you the formula. So if the formula is like this, or frequency is beside wavelength, it simply means that you will multiply the given value of frequency by the given value of wavelength. Just like here, B is equal to F times lambda or wavelength. Let's say for example, the problem is asking you to compute for the frequency. Using the triangle method, just cover the missing variable or frequency. Then it will give you the formula or equation. So V or velocity is over lambda or wavelength. So it means that you will divide the given value of velocity or speed by the given value of wavelength. So this is the equation. F is equal to B divided by lambda or wavelength. The third equation using the triangle method is cover the missing variable. Let's say for example, the missing variable is wavelength. Just cover it. So it will give you the equation or formula. B is over F. It simply means that you will divide the given value of velocity or speed by the given value of frequency. So the equation is like this. Wavelength is equal to V divided by F. So again, these are the 3 equations for wave equation. Another important thing that you should remember when you deal with wave equation are the units and symbol. For velocity or speed, the unit is meters per second and the symbols are small letter m slash small letter s. For wavelength, the unit is meter, the symbol is small letter m. For frequency, the unit is hertz, the symbols are capital H and small z. Please do remember all these units and symbols because you need this when you write the final answer in each problem. Allow me to present to you the method that you will use before computing or solving the problem involving wave equation. This method is what we call GESA method. GESA method is an easy to remember acronym that breaks practice problems into 5 basic steps. So what are the 5 basic steps? G stands for given, U stands for unknown, E stands for equation, S stands for solution, and A stands for answer. In the given, you have to identify the given information in the problem, like what is the given value for wavelength, frequency, or speed. For the unknown, it is usually mentioned in the problem. So what do you solve for? Equation, it is the formula or equation that you will use in order for you to solve the missing variable. Solution, this one you just simply substitute the numbers in the given, then proceed with the operation. Answer, after your computation, you just write the answer. And please don't forget to write also the unit for that particular variable that you're trying to solve. Now it is our time to apply the things that we've learned a while ago, like the different equations of wave equation, the units and symbols, and the GESA method. Let's now solve the sample problem number 1. A wave has frequency of 60 Hz and a wavelength of 15 meters. What is the speed of the wave? So using the GESA method, let's identify the given. The given are frequency, which is 60 Hz, and wavelength, which is 15 meters. Now the unknown is velocity or speed. It is mentioned in the problem. What is the speed of the wave? The equation is using the triangle method I mentioned a while ago. Let's cover the B, and then the formula that will appear is F multiplied by lambda, or frequency multiplied by wavelength. So this is the formula. Velocity or speed is equal to frequency times wavelength. For the solution, let us now substitute the given value. So the frequency is 60 Hz, and then the wavelength is 15 meters. Multiply 60 by 15, the answer is 900. And since the missing variable here is speed, and then the unit for speed is meters per second, so this is what we're going to put after our answer. So the final answer here is 900 meters per second. So that is the speed of the wave. Let us now proceed with sample problem number 2. A wave has frequency of 8 Hz and a speed of 32 meters per second. What is the wavelength of the wave? So let us now identify the given. The given are the following. The first one is frequency 8 Hz and velocity or speed is 32 meters per second. So what is now unknown? The unknown in the problem is wavelength. Again, it is mentioned in the problem. What is the wavelength of the wave? So what is now the equation? Using the triangle method, so let us now cover here the wavelength, and the formula that will appear is B over F. So it simply means that we will divide B by F. So the formula now is wavelength is equal to velocity or speed divided by frequency. So what is the solution? Let us now substitute the given value. So we have here 32 meters per second, that is the speed or velocity, and 8 Hz, that is the frequency. Let's now proceed with operation, which is division. 32 divided by 8, the answer is 4. Since we're talking about here wavelength, and the unit for wavelength is meter, so this is what we're going to use for our unit. So the final answer is 4 meters. Let us now proceed with sample problem number 3. A wave has a wavelength of 20 meters and a speed of 560 meters per second. What is the frequency of the wave? Let us now identify the given in the problem. The given in the problem are wavelength 20 meters and speed or velocity 560 meters per second. So what is now the unknown in the problem? The unknown in the problem is frequency. Again, it is mentioned in the problem. What is the frequency of the wave? So what is now the equation? Using the triangle method, let's cover the frequency here, or the F. Then it will give us the equation. The equation is B over lambda, or the equation is frequency is equal to speed divided by wavelength. So let's now proceed to the solution. The solution is, let's substitute the value of speed and the value of wavelength. So the speed here is 560 meters per second, and then the value of wavelength here is 20 meters. Let us now proceed with the operation, which is division. 560 meters per second divided by 20 meters. The answer is 28. Since we're talking about here frequency, and then the unit for frequency is hertz. So this is what we're going to put as our unit. So the final answer is 28 hertz. I will show you a certain problem wherein the given value of velocity is in the scientific notation format. So if that is the case, how are we going to solve the unknown or the missing variable? So let me show you the way of solving it by answering sample problem number 4. Electromagnetic waves travel through space at a speed of 3.0 times 10 raised to 8 meters per second. The radio waves emitted from a distant galaxy have a wavelength of 25 meters. Calculate the frequency of the radio waves emitted from the galaxy and give the unit. So what are the given in the problem? We have here the velocity or speed of light, which is 3.0 times 10 raised to 8 meters per second, and a wavelength which is 25 meters. So what is unknown in the problem? The missing variable in the problem is frequency. Again, it is mentioned in the problem. Calculate the frequency. So what is now the equation? Using the triangle method, we will cover the missing variable, which is f or frequency, and then it will give us the equation. So the equation here is v over wavelength or lambda. So now the equation that you will use to solve this problem is f is equal to v divided by lambda or wavelength. Now what is the solution? Let us now substitute the given value with the formula. So the speed of light here, or the velocity, is 3.0 times 10 meters per second, and the value of wavelength here is 25 meters. So as you can see, the speed here is in the scientific notation format. So what is scientific notation format? So we have here the 3.0, we call it coefficient, and then times 10, that is the base, and 8 here is the exponent. So if that is the problem, how are we going to divide it? This one is quite easy. All you have to do is to divide the coefficient by 25. So when you divide it, it will give you the answer 0.12. Then copy the base, which is times 10 raised to 8. And then what is the unit? So as you can see here, m is in the numerator and another m is in the denominator. So when you divide m divided by m, it will give you 1. And then copy the s in the denominator. So 1 over s. 1 over s is also equal to 1 hertz. So since the missing variable here is frequency and the unit for frequency is hertz. Now look at the answer. So the answer is in decimal form. So we have to make it in a whole number. So we will just move this decimal point to the right to make it a whole number. So it looks like this one, 1.2. And then copy the base and exponent. But as you can see, the exponent here changes into 7. So why is that so? Since we move the decimal point here to the right, so it simply means that you will subtract 8 from 1. Then it will give you 7. So the final answer here now is 1.2 times 10 raised to 7 hertz. So that is now the frequency of the radio waves emitted from the galaxy. Finally, we're done with our discussion on wave equation. I hope that you're able to understand how to solve a certain problem about wave equation. So it's time for you to do the practice exercise. So I have here 3 problems. All you have to do is to solve this on your own. Then comment your answer in the comment section of this video. Practice exercise number 1. A wave with a frequency of 28 Hz has a wavelength of 6 meters. At what speed will this wave travel? Practice exercise number 2. The speed of a wave is 55 meters per second. If the wavelength of the wave is 1.25 meters, what is the frequency of the wave? Practice exercise number 3. A wave with a frequency of 400 Hz is traveling at a speed of 160 meters per second. What is the wavelength of the wave? Good luck, and hopefully you're able to answer each question correctly. Finally, we're done with our video discussion. I hope that you're able to understand our lesson about wave equation. I hope that next time you will join me in my science video discussion. Thank you for listening.